Built World is a design competition-based civil, environmental, and geospatial engineering enterprise. Here is a short synopsis of the work done by each of the 7 teams.
The EPA Campus Rainworks Challenge is a green infrastructure design competition. Green infrastructure is the practice of restoring or mimicking natural hydrological processes by capturing rainwater where it falls. The challenge involves teams of students identifying a topic relevant to their campus and creating goals and objectives.
Our team began our design process by looking at the MTU master plan and focusing on the leadership in energy and environmental design or LEED goals for future buildings, starting with the new HSTEM building and how green infrastructure could improve its LEED score.
Planter boxes, rain gardens, a rainwater collection system, and increased vegetation were chosen for the HSTEM. A guide for green infrastructure on campus can be created and applied to other buildings. The team decided to create a plan for the East Hall as an example for the application of future green infrastructure planning.
Hello, my name is John Wright. I'm a fourth-year civil engineering major here at Tech and president of the Steel Bridge team. Each year, our team designs and fabricates our own 20-foot-long bridge that can be split apart into 3.5-foot-long sections via bolted connections. Once that's done, we'll go to competition and race to assemble our bridge as fast as possible and see how it performs under different loadings, usually around 2,500 pounds. It's a really good way to get some hands-on experience in structural engineering and project management, or if you're interested in just learning how to weld, we're good for that too. We'll teach you. We are part of Built World Enterprise, so if you're interested in getting some credit out of it or maybe doing it for senior design, that's an option. We also exist as our own club. So our meetings are in Dillman 101 at 6 p.m. on Tuesdays, or you can drop by one of the enterprise meetings to come meet us. Thank you.
Our team is participating in the Airport Cooperative Research Program's University Design Competition. Our challenge area focuses on methods for improving runway safety during airport construction and reconstruction.
We are working to enhance NOTAMs, which stands for Notices to Air Emissions. Our submission falls under the Airport Safety, Operations, and Maintenance category of the challenge.
NOTAMs are key for keeping pilots aware of anything abnormal to typical flight conditions. This year we have been researching ways to improve safety, especially in regards to pilot-related error.
We have met with pilots, aviation planners, and other airport professionals. We've also met with human factors and psychology professors to learn more about how humans take in information and how our project could better serve pilots.
Our solution involves a highly visual revamping of how NOTAMs are defined. Additionally, we have implemented a new class system and acronyms to make NOTAMs easier for pilots to understand and comprehend. We have also implemented prioritization of information, making sure that the most important NOTAMs are displayed first, with charts, maps, and diagrams applied when necessary.
We have developed cost-benefit analyses and safety risk matrices to ensure that our decision-making leads to the best possible solutions. Currently, our solution has been commended by a pilot who we have been in contact with for the duration of our project. We look forward to finalizing our solution in the upcoming months.
Hey, what's up, y'all? We're Work Team 4. I'm Dylan.
And I'm Ian.
So, for our design, we're trying to make a modular carbon dioxide removal system, so it's basically got to be cheap, it's got to be easily scalable, and yeah.
So our design specifically currently for the bench scale, what we have is we're going to have a long plastic tube that we're going to be filling with a bunch of plastic, and on this plastic the algae will grow, and at the bottom of the system will be a pool of water which will then be pumped up via a pump to the top where it'll trickle down through the algae, and in that water will be a diffuser stone in order to diffuse some CO2 and oxygen into the water.
Yeah, so basically what Ian said, our system is going to get rid of CO2 through photosynthesis from the algae, and right now we've gotten most of our tube done, and pretty soon we're going to start testing with algae, and yeah, we'll see how it goes.
Hi, we're the Timber Strong Design Build team here at Michigan Tech University. We are comprised of environmental engineering students as well as civil and construction management.
Our competition is a timber structural design competition where we build within the parameters of 6 foot by 6 foot by 12 foot with a 2-story tall wooden structure, and we do a deflection test at the end of the beam with given parameters.
Currently, we're on our fabrication stage of the project. Here you'll see one of our prefabricated walls before it's sheathed, and then this is our first story completely completed in fabrication. After the entire building is fabricated, we'll practice putting it together before competition in April.
See all this snow here? In just a few short months, it will all melt, and just across the way in Dollar Bay, they will experience extreme flooding due to poor infrastructure and lack of funding. But not anymore, thanks to WERC Team 1.
Green infrastructure solutions such as this green roof reduce urban pollutants and urban runoff. The green infrastructure we will be using are bioretention cells and bioswales, which are different layers of soil and rocks which filter out pollutants.
Due to the high amounts of snowfall up here, we use large amounts of road salt. We will be using biochar and kaolin clay in order to remediate the chloride within our runoff.
Let's save Dollar Bay!
Hi, this is Becca, Dylan, and Tanya from Engineering Without Borders team in the Built World Enterprise. We are currently working with 2 adjacent communities in Guatemala, Canton and Fronterizo, and we are planning on an implementation trip to construct a new water supply project.
The project will be in Fronterizo. We are planning to build a new water system that will provide around 20 gallons per person per day. We are deciding between a shallow well dug with a mechanical auger and a deep well dug with a boring rig, but we're also keeping our options open to other methods, like looking for more springs for a spring box project.
One of our favorite parts of our team is that our project is built for real use in communities abroad. With that, there's a lot of project management experience and traveling to do construction, which has a lot of rewarding and fun benefits.
Thank you all for listening. I hope you all enjoyed this video as much as we enjoyed making it. Please feel free to stop by our booth at Design Expo to learn more about each one of these projects and ask any questions that you have. Thanks again, and have a great day.